All right, ladies and gentlemen, this is 5.1 for geometry. We're talking about ratios and proportions. We're starting to talk about similarity. And in geometry, when you talk about two things being similar, that has a very, very specific meaning. So when you talk about ratio and proportion, you're talking about actually measuring what the ratio is from two things that are similar. And similar has a very distinct definition in geometry. So when you're looking at a comparison of two quantities using division, it's a ratio. For all intents and purposes, it is a fraction. All right. If I've got 4 blocks and my son has 6 blocks, the ratio is just 4 to 6 or 4 to 6. So there's many different ways that ratios are written. This is one of them. It's like 4 to 6. That'd be one way a ratio is written. 4 to 6 is another way that a ratio is written. So a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks. Walks are not included in this. So Joe Mauer had the highest batting average in 2006 in Major League Baseball. He had 521 official at-bats and 181 hits. Find his batting average. So he had 181 hits at 521 at-bats, when he wasn't broken. So 181 divided by 581 is going to be 0.3098, so 0.310. So his batting average was 310, and all I did was compare the ratios. So now take a look. The number of students that participate in sports programs at Central High School is 520. The total number of students is 1850. Find the athlete to student to ratio. So the ratio is nothing more than 520 to 1850. Now, be a good math student. Simplify this, break this down as simply as possible. So the easy one to do is this. So that's 52 to 185. I'm not 100% sure there's anything else that can be divided there. So I think this is going to be it. Your simplest ratio is going to be out of every 185 kids, 52 of them will be an athlete in some way, shape, or form. A ratio can also compare more than two numbers. This is called an extended ratio. So you've got the first two quantities, you've got the second two quantities, then you have the first and last quantities. So let me give you an example of kind of what that means. So if the ratio to measure the angles in a triangle is 3, 4, 5, find the measure of the angles. So once again, triangle stuff never seems to go away, does it? So all that means is that for ABC, like this is going to be 3, this would be 4, this would be 5. So like this was 30, this would have to be 40, this would have to be 50. If this was 60, this would have to be 80, this would have to be 100. But slight problem, we're kind of limited by this because a triangle still has to add up to 180. So here's kind of the way I kind of think about it. It's going to be some ratio, shape, or form of x. Okay, so 3x, 4x, 5x, that's going to be kind of the ratio. And all three of those together have got to add up to 180. So what I do is I kind of measure it all against one common thing, and that's kind of what the x is representing. So if I've got 12x equals 180 divided by 12 divided by 12, that's going to give me 1, 5, 15. So x equals 15. So now to figure out the three angles, I'm going to put that back in here and figure out what that is. So 3 times 15 will be 45. 4 times 15 will be 60. 5 times 15 will be 75. And that works. 45, 60, 75. Going back, if I simplify the ratio of 45 over 60, that gives me 3 over 4. 60 over 75 gives me 4 out of 5. 45 out of 75 is going to give me 3 out of 5. And that is the ratios that I started with. So in a triangle, the measure of the sides is 338 and the perimeter is 392. If Find the length of all three sides of the triangle. So same kind of idea, although 3, 3, 8 indicates that this would be an isosceles triangle. All right, so but it's going to be the same kind of idea. All of this is a ratio, and they're all going to add up to 392 inches. All right, so there's a common number. I'm multiplying it by 3 twice, and I'm multiplying it by 8 once, and it's going to add up to 392. So that's going to be 14x equals 392. A little division. And again, I throw the x in there just so I can use it to measure. All right, it's going to help me figure out what the two side lengths are, and it's going to help me figure out what the final piece is. So that's going to be 28 when I divide it. So that means these two sides are going to be 84. 28 times 8 is going to be 224. So that's going to be the side that I'm looking at. Now, Jane jogs the same path every day in the winter to stay in shape for track season. She runs at a constant rate, and she spends a total of 39 minutes jogging. The ratio of the times of her 4 legs is 3, 5, 1, 4. How long does the second leg of the jog take her? All right, so we're measuring her speed here. Okay, so it goes 3, 5, 1, 4. That means her third leg was the fastest, her first leg was the second fastest, the last leg was third fastest, and the second leg was the slowest. All right, so what we're trying to figure out is, this is the ratio, the comparison of each one of the legs, and the entire time was 39 minutes. So, you know, I'm going to kind of do the same thing I've been doing, except now I'm trying to figure out what that is. Except now I'm trying to figure out what that is by comparison. So 8, 12, 13. So on her fastest time, which was this third lap, it took her 3 minutes to run that lap. So the first one took 9, the second one took 15, third one took 3. She was really hauling for that one. The last one took 12. It took it all out of her. So the second leg is just going to be 15 minutes. So proportions, two ratios that are equal. To solve proportions, you cross multiply, and I don't like using cross multiply. Cross products is a better definition. And here's what I mean when I say that. Cross multiply implies you're going to multiply across things. Cross products means you're going to go diagonally. So you're looking at multiplying diagonally. So you take 8 times x and you take 5 times 12. So 8x equals 60. A little division, and that will give you 7 1/2. So now it doesn't change just because I start putting binomials, two-term things in here. Be careful in here. Keep your algebra skills sharp. So now subtract 2x, subtract 2x, subtract 16, subtract 16. Zeros out, negative 20. And that's going to be 2x, so x will equal negative 10. Down here at the bottom, ooh, here's where things get a little bit clever. So I get 2x plus 3 times x minus 1 equals 6 times 3. So here, foiling, coming back to make a rare appearance. Minus 2x plus 3x will be plus x minus 3, and that will be equal to 18. So now I need to bring this over. Now I need to factor that. For those of you guys that forgot how to factor, we shall go through it very quickly and refresh your memory. So I have 2x squared plus x minus 21 equals 0. Now, this is where you take the first thing times the last thing, so 2 times 21, and you're going to get 42. Now I'm going to take factors of 42 that subtract to 1. So it multiplies to 42, subtracts to 1. Well, 7 and 6. So now, since I've got 7 and 6, I'm going to rewrite that. Technically, it's going to be 7 and negative 6. I'm going to rewrite this middle term using 7 and 6. So it's going to be 2x squared. It's going to be minus 6x plus 7x minus 21. See how 1x becomes minus 6 plus 7? I got the 7 and the negative 6 for my factors, and that's all I get. So now, I box the first two, box the second two, leave the addition alone, and here's what I do. What's in common here? Well, 2x. I'll be left with x minus 3. What's in common here? 7. I'll be left with x minus 3. So now, since these two are the same, I can say, well, that's nothing more than this times this. So what are my possibilities for an answer? Since it's equal to 0, I set each part equal to 0. So that's going to be 2x plus 7 equals 0, x minus 3 equals 0, so x equals 3, or x equals negative 7 and a half, or negative 3 and a half. So there's my answers. X can equal those things. That is a great review of your algebra. Katie surveyed 30 students for a class and found that 18 owned an iPad. If there were 870 students in Katie's school, predict the total number of students with an iPad. So 30 students, 18 out of 30 own an iPad. There's 870 students in the school. How many own an iPad? Same kind of idea. So 30x will equal 870 times 18. That'll be 15,660 divided by 30. So out of those, that many students, 522 of them will have an iPad. So Shelley can read 20 pages in 30 minutes. At this rate, how long will it take her to read 152 pages? So if she can read 20 pages in 30 minutes, how long will it take her to read 152 pages? So on the bottom is your minutes, on the top is your pages. So what is going to be that comparison? Well, let's simplify life here. 20 over 30 can be simplified to 2 over 3. So I get 2x equals 456 divided by 2. So x will equal 228. So it'll take her 228 minutes to read that entire book. All right, so 228 minutes that will read her entire book. Please notice I was solving for minutes, so my answer will be in minutes. That's all I got. Please look over this. Go back and look at the factoring one more time. Watch and see what I did, and that will come back and help you a lot. Thank you very much for playing. We will talk to you in class.